So for our problem, we had the natural log of x squared minus 16. And when you want to take the first derivative of it, the principle of natural log is always ln x is always 1 over x. So you would end up having 1 over x squared minus 16 times the derivative of the inside, because this is chain rule. So you get 1 over x squared minus 16 times 2x, which simplifies to this, 2x over x squared minus 16, because 2x is also viewed as just 2x over 1. So you multiply those out, simplify it, and that's what you get. And our original function would be this green line up here, and the derivative, which is this, is the blue line down here. And for the second derivative, you want to use the quotient rule, which is always low d high minus high d low over square low, which is right here. And when you simplify it out, you get 2x squared minus 32 minus 4x squared over x squared minus 16 squared. And as you can see, our original function is the green line, and the blue one is the second derivative, which ends up being a polynomial, so it is in the shape of a parabola. For the inflection points, you want to take your second derivative and set it equal to 0. And when you do that, you don't care about the denominator in this case, so you'd have 2x squared minus 32 minus 4x squared, which ends up being negative 2x squared minus 32. And then you subtract or add 32 to the other side, so you get negative 2x squared equals 32. And then you would divide by negative 2, so you get x squared equals negative 16. Square root of that would be x equals plus or minus 4. And that are your inflection points. Those are the x values. Now if you wanted to find the y values, you take 4 and negative 4 and you plug it back in to the original equation right here. And those would be your y values. So if you want to find an exact coordinate point for your inflection points, that's how you would do that. And that is about it. Thanks a lot.